All right, guys. So we have to know how to write the equations of lines. And we're going to talk about that plus some other vocabulary and how to recognize it. All of this is in reference to on a coordinate plane, a 2D coordinate plane. So let's talk about the first one, parallel lines. The symbol for parallel is like the double bars. Parallel lines, we know, are going to have the same slope. Remember, slope determines what direction you're going. So if you have the same slope, you're going the same direction. And they have to have a different y-intercept. Same slope, different y-intercept. An example of parallel lines would be like y equals 7x plus 10 and y equals 7x plus anything other than 10. So I could say plus 11, I could say plus 20, it doesn't matter. Anything other than 10. Now if I said y equals 7x plus 10, that's something else. That's called coinciding. We're going to talk about that in a second. Perpendicular lines, that symbol is an upside down T. And they have opposite reciprocal slopes. Reciprocal. Opposite means the plus and negative, plus and minus. Reciprocal is when you flip the denominator and the numerator. So when you do both of those things, what happens? A fraction a over b becomes negative b over a. For example, if you had y equals 7x plus 10, the perpendicular line would have to be negative 1/7 x plus anything. It could even be plus 10, that's fine, because plus 10 is not the exact same line. So opposite reciprocal slopes. Coinciding lines, I don't know about a symbol for those, so I don't think they really have one. But coinciding lines are just the same line. That means same slope. That means same y-intercept. Examples would be like y equals 7x plus 10 and y equals 7x plus 10. Those are the same line. They're overlapping. We call those coinciding lines. And then intersecting but not perpendicular. What's going on there? This just means different slopes. Different slopes. As long as they're not opposite reciprocals. Because if they're opposite reciprocals, then they're perpendicular. So intersecting lines but not perpendicular just have to have different slopes. For instance, y, so an example would be like y equals 7x plus 10 and y equals negative 7x plus 10. As long as the slopes are different but not opposite reciprocals, they're going to hit. Like if you had like y equals 7x and y equals 7.1x, those are going to hit. You know, it might take a while, like it might look something like this. Well, actually, those hit at 0, don't they? Because they both are going to hit there. Boop, they're going to hit. Doesn't matter what the slopes are. As long as they're different, they're going to hit. All right. So we have to understand all that information. Well, how do we actually get the slope? So I treat slope very much like I treat distance. So on a graph, like if you put right 2 up 3, something like this, 2 comma 3, left 5 up 10, left 5 up 10 might be up here. Right? The slope is the rise and the run. That is your delta y and your delta x. It's the same numbers that we use for distance. It's just this time we do care which way we're going. Remember distance, we didn't care which way. We just cared about how far. So like negative 5 and 2, those are 7 apart. We didn't care if it was plus 7 or minus 7. But with slope is all about direction. Yes, we care about the direction. So the slope is, the letter M represents slope. It is the change in y over the change in x, also known as the rise over the run. Y, rise. The rise is your y's. Okay. So what does it look like on an actual situation? If I had these two coordinates, the slope, I'm going to look at the y values. How do I go from 3 to 10? I'm going to add 7. How do I go from 2 to -5? I'm going to subtract 7. I didn't mean to make it like that, but oh well. So we do care about the direction. If this was distance, we would have just said 7 squared plus 7 squared. We didn't care plus or minus. We didn't care. It's the same numbers, but now we care. 3 to 10 is plus 7. 3 plus 7 gets me 10. 2 minus 7 gets me -5. That's a slope of -1. Let's do another one real quick. Let's say it's 2, 3 again. And let's say it's like 5, comma, -10. So same premise. What would be the slope? We do the y values. 3 to 10. How do you go from 3 to 10? You do -13, minus 13. How do you go from 2 to 5? You add 3. So that is the fraction -13 thirds. That's the slope. That's the slope. So with that in mind, let's go solve and write some equations. Nope. We got to write the equation first. Okay. How do you write an equation? We always start with the format y equals mx plus b. Different teachers are going to show you this different ways. I like y equals mx plus b. So let's say that we have, point A at 2, comma, -1, point B at 6, comma, +1. I don't know. I'm just making something up. I don't care. So I'm going to write the equation for the line AB. So what is that equation? I need two things. I need a point and a slope. Well, I already have a point, right? A or B. I have both of them, so I can pick. It doesn't matter which one I use. But I do need the slope. So let's do that first. So what would the slope be? Look at the y values. -1 to 1, that's +2. The x values, 2 to 6, that's +4. That is a slope of 1/2. You must be fully simplified to get full credit. So +2 plus 4 reduces to a +1/2. And then because it's called AB, I can choose either A or B, and I have both of them. So it does not matter which one I pick. Makes no difference. I'm going to choose B, just for fun. This is my x and this is my y. So what we're basically saying is x equals 6 and y equals 1. A coordinate is an x comma y situation. All right, so then I plug it into y equals mx plus b. So the y value is 1, right? I'm just using this y value, right? That's this y value. It's 1 equals the slope, 1/2, times x. My x value is 6, right? X is 6 plus b. So 1 equals 3 plus b, so b equals -2. So my equation would be y equals 1/2 x minus 2. Could I check my work? Yes. Yes. This is another xy. Could I plug that in? When I plug in 2, 1/2 times 2 minus 2. Half of 2 is 1 minus 2. That's -1. What did it need to be? It needed to be -1. I could plug in 6 as well. The answer should be 1 when I plug in 6. So yes, I can check my work. All right, so that's how you write the equation of a line. You plug it into y equals mx plus b. You have to find the slope first, and then you have to use one of the coordinates that the line goes through. So let's go work some problems out. Let's start with this one. Write the equation of line AB. So this particular problem, we need the slope, obviously. So we start at 3, go to 6, that's +3. 2 to -2, that's -4. That is -3/4. And I need to hit A and B. So I need to pick A or B. It doesn't matter which one. I'm going to go with A this time. So my x is 2 and my y is 3. So y equals mx plus b. I plug in 3 for y. I plug in -3/4 for m. And I plug in 2 for x. Right? 3 for y, 2 for x, -3/4 for m. Now just clean this up. Now we're just solving. 2 divided by 4, that's 1/2. So 3 equals -3/2 plus b. So then I add 3/2 to both sides. We need to get better at this. I'm not going over fractions right this second, but that's going to be 9/2. You do need to figure out how to do that at some point, though, my friends. For right now, you can use a calculator, but you need to be trying to figure that out. We will go over it again later. So the equation is y equals -3/4 x plus 9/2. We're going to do some more. It says, write the equation for AC. Mr. Ben, there's no C. I know there's no C. Let's not sweat that just yet. If AC is perpendicular to AB. Okay, so if it's perpendicular to AB, what can I do? I can find the slope of AB, which I got. I got A and B, so let's do that first. So the slope of AB, -1 to 5 is +6. 2 to 10 is +8. Clean that up, that's 3/4. So the perpendicular slope would be -4/3. So we know we're working with -4/3. So what do you need to write the equation of a line? You need a slope, which we got a slope, and a point. What equation am I trying to do? I'm trying to do AC. So I could use A or C. There's no C. I know there's no C. I don't care that there's no C. I got A right here. I don't need both. I need one. I need a slope and a point. I got a slope. How did I get the slope? It's perpendicular to AB. So I found the slope of AB, and I did the opposite reciprocal. Those are perpendicular slopes. If I have to write the equation of a line perpendicular is just code for opposite reciprocal slopes. So I've got the slope. Now I need to use the point, in this case A. So y equals mx plus b. My y value is -1, right there. Y is -1. M, we said, is -4/3. X is 2 plus b. So we plugged in y, we plugged in x, we plugged in m, we're solving. So -1, this would equal -8/3 plus b. So we're going to add 8/3. So b equals 5/3. So it's going to be y equals -4/3 x plus 5/3. -4/3 x plus 5/3. Love it. Let's do another one. So they gave us A and B. Write the equation for CD. Oh, goodness. I hear you crying now. There's no C, there's no D, there's nothing. I know. Calm down. We got this. We got this. We will get there together. Let's keep reading before we panic. Write the equation for line CD if CD is parallel to AB. Well, parallel lines have the same slope. So we can get the slope of AB and use it for CD. They're the same number. So let's do that. So what's the slope going to be? 10 to -7 is -17. 3 to 4 is +1. So that just reduces or simplifies to -17. Okay. So I have the slope. Now I need an x and a y. I need a coordinate. Look what they gave us. Look how nice they were. The coordinates of D are 1, 1. That's my x, that's my y. Why do I want to use that x and y? Because it has to be the equation CD. I only have two choices that I know about, C and D. I don't have C anywhere in the problem, but I have D. D is the one I'm going to use. So y equals mx plus b. I'm going to plug in my y value, 1. My slope is -17. My x value is also 1. I'm going to solve for b. So that would be -17 plus b. b equals 18. Y equals -17x plus 18. Fun problem. One more. Determine if A, B, and C, D are all that. So this could be a fast problem depending on the slopes. If we get the same slope, we do need to find the y-intercept because we have to decide, are they parallel or coinciding? But if they're not the same slope, then we can actually just tell by the slope. But I'm going to go ahead and practice writing the equations no matter what. So AB, so let's work on AB over here. AB, 3 to negative 1, it's minus 4. So the slope is minus 4. 2 to 3 is plus 1. That's a slope of negative 4. Let's work on CD. Let's get the slope. See what's happening over here. CD, 4 to 8 is plus 4. 4 to 5 is plus 1. Well, that's a slope of 4. So I know right now, just based off the slopes, that they are not parallel. They are not coinciding because those have the same slope. They are not perpendicular because those would be opposite reciprocal slopes. I know right now that the answer is this. So they have to hit each other. They have different slopes. Let's go ahead and finish this by writing the equations. If I was going to write the equation of AB, I could use point A or B. Both points, A and B, are eligible. So I'm going to use A just for funsies, 2, 3. So we have y equals mx plus b. I'm going to plug in 3 for y. I'm going to plug in negative 4 for m. I'm going to plug in 2 for x. So 3 equals negative 8 plus b. b equals 11. So this is y equals negative 4x plus 11. This is just for practice, by the way. Just for practice. You don't have to do this. Over here, CD, does not matter which one we pick. I think 4, 4 looks pretty fun. But you could use point D. But I'm going to use 4, 4. I'm going to make this my x and my y. So y equals mx plus b. I'm going to plug in my y value, 4, equals m, 4, times x, 4. Oh my gosh, they're trolling us, plus b. So 4 equals 16 plus b. b equals negative 12. y equals 4x minus 12. So that was just for practice. We already had the answers. You have to know how to do this stuff. Let's go.